ሰላም እንዴት ናችሁ? በዛሬው ቪዲዮ ያዘጋጀሁላችሁ ኤሌክትሪካል እና ኮምፒውተር ኢንጂነሪንግ ተማሪዎች ሞዴል ኤግዚት ኤግዛም ኩዌስችንስ ዊዝ አንሰርስ ነው። የመጀመሪያው ጥያቄ in a PNP transistor the current carriers are blank. A acceptor ions, B holes, C free electrons, D donor ions. ወይ PNP transistor current carrier ማነው ነው? PNP transistor is a BJT or bipolar junction transistor which is formed by sandwiching the N-type semiconductor between two P-type semiconductors. The majority carriers in a PNP transistor are holes. Therefore, holes are responsible for current carriers or responsible for current flow. Therefore, the answer is B. That's holes are the current carrier in a PNP transistor. ሁለተኛ ጥያቄ the data elements in structure are also known as A. objects, B. instruction, D. member, D. data. The answer for this question is A. Objects are the data elements in structure. ሶስተኛ ጥያቄ which among the following assertions represents a necessary condition for the existence of a transform of discrete time signal or DTFT? A. Discrete time signal should be absolutely integrable. B. Discrete time signal should be absolutely multiplicable. C. Discrete time signal should be summable. D. Discrete time signal should be absolutely differentiable. One necessary condition for the existence of Fourier transform of discrete time signal or DTFT is discrete time signal should be absolutely summable or should be convergent. Summation of the given discrete time signal should be convergent or summable. Therefore, the answer is C. አራተኛ ጥያቄ a type of assembly language instruction that alters the course of the program is called A. flowchart, B. loop and jump, C. loop, D. jump. The answer for this question is D. jump. Jump is a loud simple language instruction that alters or changes the course of the program. አምስተኛ ጥያቄ according to Relay's theorem it becomes possible to determine the energy of a signal by A. estimating the area under the 1/4 power of its amplitude spectrum, B. estimating the area exactly half as that of its amplitude spectrum, C. estimating the area under the square root of its amplitude spectrum, D. estimating the area under the square of its amplitude spectrum. Relay's theorem states that if the energy of a signal is finite or convergent, then it could be evaluated from its spectrum. So the answer is D. estimating the area under the square of its amplitude spectrum. The relay theorem states that if the energy of signal x of t is finite, then it could be evaluated from its spectrum. That means the integral of the norm of the given signal, let's say x of t, is the energy of a signal x of t is equivalent to the integral of the norm of the complete square of the spectrum. That's this ECE for the spectrum is the Fourier transform of the given signal x of t, and the integral is equivalent to the area. Therefore, according to Relay's theorem, the energy of this signal can be determined by estimating the area under the square of its amplitude spectrum. Yes, the answer is D. Or question 6. Question number 6. Which one of the following an example of hardware? A will be data, B instruction, C memory, D program. Among these choice, memory is hardware. The rest are not hardware. Therefore, C is the answer. Question number 7. How many full adders are required to build a 7-bit replicatory adder? A 7, B to the power of 6, C 8, D to the power of 7. To build a 7-bit replicatory adder, 7 full adders are required. So the answer is A. That is 7 full adders are required to build a 7-bit replicatory adder. Each full adder inputs a carry in bit, which is the carry outbit of the previous adder. This kind of adder is called a replicatory adder. Number 8, or question number 8. The invalid state of an SR, the invalid state of an SR latch occurs when A is equal to 1 and R is equal to 0, B S is equal to 0 and R is equal to 1, C S is equal to 0 and R is equal to 0, D S is equal to 1 and R is equal to 1. The invalid state of an SR latch or the non-mutable state of an SR latch occurs when both inputs, that means both set and resets, are active simultaneously, or S and R are at high state or are high, when both are high. So the answer is D, that is S is equal to 1 and R is equal to 1. Question number 9. In which of the following the file is seen in self-defined in C++? A. iomanip.h, B. iostream.h, C. fstring.h, D. iocode.h. From these header files outstream.h describes or represents the input and the output stream. Therefore, the answer is B. Header files available in C++ for input and output operations are stream, F stream, manip.h, and so on. Outstream stands for inputs. Outstream stands for standard input-output stream. This header file contains definition of objects like in, cout, and so on. And the next manip stands for input-output manipulators. And this header file declared in the files are used for manipulating stream. Third is F stream. This header file mainly describes the file stream. This means it is used to handle the data being read from a file as an input or data being written into the file as an output. There is also another header file as speech or STD C++. This header file includes every standard library. As explained before, the string stands for standard input and output stream. So now, in an n-type semiconductor, the position of Fermi level is A, in conduction band, B, in valence band, C, near valence band, D, near conduction band. In any type semiconductor, the position of Fermi level is near to or close to the conduction band, because the number of electrons in the conduction band is greater than the number of holes in the valence band. Hence, the probability of occupation of energy levels by the electron in the conduction band is greater than the probability of occupation of energy levels of holes in the valence band. There, the answer for this question is D, that's near conduction band. This is the energy band of n-type semiconductor. It has 3 bands. The first is conduction band, an energy band filled with electrons. Second is forbidden band, the gap between the conduction band and the valence band. Third is valence band, an energy band filled with holes. As you can see from this diagram, the Fermi level is near to or close to the conduction band, but it's below the conduction band. Conduction band, an energy band filled with free electron, and Fermi level is the highest energy level that an electron can occupy at absolutely zero temperature. ይህ ያየነው ዲያግራም የኤን ታይፕ ሴሚኮንዳክተር ሲሆን ፒ ታይፕ ሴሚኮንዳክተር ቢሆን ደግሞ the Fermi level in the p type semiconductor is above the valence band, or it lies close to the valence band ይሆናል ማለት ነው። 11 for a two-port network, the condition of symmetry of Y parameters or admittance parameters A H11 is equal to minus H22, B Y11 is equal to Y22, C Y12 is equal to Y21, D Y12 is equal to minus Y21. The condition of symmetry of Y parameters is Y11 is equal to Y22. So the answer is B. The condition of symmetry for Y parameters is Y11 is equal to Y22, and the condition of symmetry for Z parameters Z11 is equal to Z22, and the condition of symmetry for two-port network in the case of each parameters is the determinant of H is equal to 1. The output of an OR gate is low when N input is high, B all inputs are low, C all inputs are high, D one input is low. An OR gate is one basic logic gate in which the output is low when all inputs are low. Otherwise, the output of an OR gate is high. So, the answer for this question is B. That is, all inputs are low. When all inputs are low, the output of this gate is low. It is equivalent to what? Summation of all inputs. The total gain of multi-stage amplifier is less than the product of the gain of individual stages due to A. The use of many capacitors, B. Power loss in the coupling device, C. The use of many transistors, D. Loading effect of the next stage. The answer is due to loading effect of the next stage. The overall gain of multi-stage amplifier is not equal to the product of the gains of individual stages due to loading effect on the next stage. Since the input resistance of the second stage forms a voltage divider with the output resistance of the first stage, that's the gain of multi-stage amplifier not equal to the product of the individual stages gain. This item is based on the following electrical circuit. Given input X and Y and the output F are also given in this diagram. The waveform of the inputs and the outputs are described here. What is the type of logic gate represented by the diagram? As you can see from this diagram, there is two inputs and one output. When both input X and Y are high, the output is also high. When input X is 1 and input Y is 0, the output is 0. When both inputs X and Y are high, the output is high. In the third, and the fourth, when the inputs X and Y are different. That's 0 and 1. The output is 0. And when both inputs are low or 0, the output is low. So the logic gate represented by the diagram is what? AND gate. That is so the answer is AND logic gate. In this logic gate, when both inputs are high, the output is also high. Otherwise, the output is low. So, and the logic gate is the diagram is presented by and the logic gate. Or and the logic gates are basically logic gates. They are used to construct other logic gates. NOR and NAND logic gates are universal gates. Thank you for watching. ለቻናሌ አዲስ ከሆኑ ሰብስክራይብ ኤንድ ላይክ ማድረግዎን አይዘንጉ። በቀጣይ በሌላ ቪዲዮ እስከምንገናኝ ሰናይ ጊዜ